know if you guys can hear me. Give me a second. I'm trying to manipulate something to make sure I'm here. Give me a second. I'm trying to. How about now? Can you hear me now? I did all that talking. Hey guys, hello. Can you hear me now? I just saw your comments. Can you hear me now? Gotta wait 20 seconds. Testing. How about now? Can you hear me now? I'll test it one more time. I think I heard it. Could you hear me from the beginning? I clearly will back this up and delete the face of this video otherwise. How about now? Can you hear me now? Could you hear me from the beginning? I clearly will back this up and delete the face of this video otherwise. I'm gonna wait for your answer. I'm gonna wait for your answer. Wait for your answer. Okay. Yeah. But should I start over? Okay. Yeah. But should I start over? Okay. I'll tell you what I'll do. I've got my cell phone, so now I can see the comments in the background, so you guys can comment as you wish. And if I see your, let me stand the phone up. I'll start over real quickly. It won't take long, I don't think. Let me back this up. So what we're looking at is Wendell Bollman is a self-taught carpenter, engineer, if you will. He was a carpenter, dead as can be now. And this bridge is a Bollman Bridge. It is a suspension bridge. Excuse me. Excuse me. It's a suspension bridge. Tomorrow I'm going to go see it in real life. It's about 2 hours away from me in Maryland. Now if we go to here, if you look it up, look up Bollman Iron Truss Bridge. It's awesome. It's going to have some details that I'm going to share with you now, and then tomorrow when we go live, hopefully I'll have the internet connection down there to do live video. You guys can show me where you want to go and what you want to see. With that said, the research, I wanted to give you guys a heads up. I want you guys to play with this thing called Trust Me also. Find this app. You can write it down and find it later. You're going to love this app, and it's addictive. I like playing it intuitively, which they actually don't do anymore, intuitive bridge building. Now, and rightly so. I'm sorry, they do. They do origami bridges down in southern Florida. So this is a truss bridge. Let's get to a big photograph of it. And maybe now you can hear me. All right. So just a text message. Sorry for that. This is a 2-span bridge. So we only have to look at this side onto this side. Divide this in half, if you will, right at that parting bead. This is the second side. Hello, Doss. What's up? Paper bridges, right? So this is a suspension bridge hanging from here. I'm sorry. So the load path. Think of these as a suspension bridge, as a cable bridge, except for this is wrought iron and cast iron combination. This is a prefab bridge that was made in a factory and then brought to the field. Look at the awesome engineering of it. And I'll show you a joint where this is an adjustable joint to, I guess I can't call it a joint, adjustable section in this member, and then I'm calling this member this iron cable now. Let's refer to it as a cable, if you will. You can adjust it upwards to put more tension to level the bridge. I mean, it's so beautiful. And I was saying, because now I can say it a little faster, that if we look at this first section, and if this cable comes down, typically you'd find it more down here intersecting with the bottom cord. But this just offset a little bit, and so this becomes what we would think of like a truss plate. And even though it's offset, everything's working great. This is the, let me check my notes. I want to make sure I didn't skip something for a second here. Hold on. Okay, yeah, about where I was. This is the floor beams, and I'll get you the end. But it wasn't an origami paper bridge, no. So now let's jump over to here, and let's give you, I was going over this. Hopefully did you guys catch this? And I'll give you the links to catch this stuff. But let's look at I'm going to go from here and back to the bridge. 10-4 over, thank you. So now, there are only 7 images, and this is a National Historical Bridge, and it's the only one existing in the world, an iron steel bridge, suspension bridge. So it's going to be it's a pretty unique structure to look at. And now they use cables instead of iron. And of course, the cables elongate. This is a 150-year-old bridge standing with no issues. Now they replace cables all the time, as we know. But this sort of reminds me of the bridge in Philadelphia with the pin design and etc. And this bridge came before the bridge in Philadelphia. This is 1869. Our bridge in Philly is 1895, I believe. So this one we're looking at 18. Let me bounce over one more. Yeah, 1869. And again, this guy was self-taught. He was born, I think, 1814, 1811, 1814. Yeah, he was like 54 years old when this bridge was built. And he was a carpenter. I'm saying, how awesome is that? And his bridge, they built over 100 of these guys because it was, it was awesome. Now, looking at this design, this is the bridge span, and they use the, let me see if I can get this out. come this way, scroll. God. I'm going to show you the bottom of the page. Historical engineering record. This is, you know, they used a real survey of this, which is kind of cool to actually have online. This is the Library of Congress that has it. They only have 7 pages. So it's up to you to figure out load paths. They seem, no engineer usually would like to try to take on this because if you're wrong, it's forever, you know, in the record that you screwed up. So when I say it, I'm just I'm theorizing load paths, but it's a truss bridge, and an individual. Don't, if you look at this one or whichever one helps your eyes, but kind of like looking at this one. They're two separate bridges, but look how this load is transferred to this column, and then all of these 1, 2, 3, 5 of them, then it's transferred to this column. Now don't leave out these members here coming down, here and here, here and here, all of it helping to level this deck and transfer the loads down these 2 columns, which they refer to as, looking at my notes, vertical post. So here are the vertical posts, and as we see, if you got rid of the top chord, this load would want to this top vertical column and this top vertical column would want to fall inwards, 79.6 feet it appears. But this then becomes in compression, this top chord, so it keeps the distance of these 2 apart, keeping the distance apart. And yet, look at the scale of it. It's really not. Let me slide over. One more image. Look at the scale. It's beautiful. And, oh, great. I don't know what I did there. And I can't go backwards. Give me a second. Okay, here we go. So, looking at. I did it again. When I touched on the image, it bounced over one. Huh. And. Oh, I got it. It's magnified. And so when I touch on it, it gets some other signal, I guess. All right. Great. Awesome. I don't really mean awesome. So here it is here. And if we zoom in, if it allows me to zoom in now, here we go. So these guys across are keeping them from coming, they're the struts. Keeping these 2 from folding in, obviously. And now we've got this little small scale of this. Beautiful. And here's your supporting column, and which they call the verticals. And those are your end verticals. Looking at my notes here, make sure I get everything right. Yep, they still call this a portal strut. So it's an end portal strut, and these are your regular struts. Awesome. And then here are these members here. Now here it is hanging here. Take note of, let's see if I can pull that down. Yeah, good. Take note of the last one. Look how small the scale it is. Isn't it amazing? And they offset it. It's lowered a little bit. No big deal. I mean, obviously it lasts 150 years. Remember, this guy taught himself. So no one taught him this. He taught himself, and then it's so solid that, you know, he got a patent on it. They did 100 bridges, and people were following his design around the world until they went to cables, etc., and changing over. But it's very simple and prefab, mixing metals, cast iron and wrought iron. And let's go over, and I think I can close these tabs out, these duplicated tabs. And I want to show you guys. And I'm going to go live tomorrow. This is someone else's article on it. Reading everyone's article. Here it is. This person says, a remarkable self-taught like many of the mechanical and civil engineers of his day. As I go out of this, I'll keep one open to give you guys a link, or you can look up Bollman. So let's go back to this. Look at, he's got adjustments everywhere. So simple. So simple. I mean, and here's your diagonal. This diagonal would be your floor diagonal. And let's get you an image of the floor diagonal, which is right here. See this one here? Let's see if I can do that. There's your floor diagonals. And it's recessed or datoed in, however this person did it. Here's a diagonal there. And I'm not sure how the drawing there, what's going on there. Queen post trussing, 1909, circa 1909, according to. So I guess they added this later, is what they're identifying. But back to here's the chord member, lateral bracing. Here's the diagonals again. Floor system showing linkage suspension. Okay, yeah, we're gonna follow all that tomorrow. Here's your eye bolts and your queen post. Let's see what we got here. Let me see if I can move around in this image. Cast iron stirrup again, and then this is left out for whatever reason, but it looks like a wood detail to me. I don't think it has wood in the current image. This will be your design, your end view, your end elevation, and those are the piers, as we know, as I'll jump over. Let me see if I can reload the comments of anything. Okay, no comments. Cool. And it's open for foot traffic. So this is what it's going to look like. There's the plaque, and there's our uprights, and there's two structures, sister structures behind each other. They didn't do anything to tie them in. I don't think they had to. Obviously, they stand alone. They stand 150 years of weather and beating, etc. There's some people having fun with it. I think I might have some fun with that too. There's a top view. I'm trying to think if I can get you guys something else. I've looked at all the typical images that I could find. There we go. Let's see if I can zoom in and get you this linkage. And using this. So this linkage is what I want to see. This is the adjustable. This bolt, you tighten it up, and it would elevate this, obviously putting more, as you look, more tension on the bottom of the deck, elevating it. So if you would imagine that one, if I could follow it up. Now that's the first one, so there was no adjustment there. So the second one out, the second one going over to the second member, you would adjust it, and it could elevate the bridge ever so much. Let's see if I can find one down here. So here it is here with my mouse. This would adjust up, pulling tension here, leveling the deck, creating a hinge. All this being able to hinge, which is amazing. Crowning the top or leveling the top, however you that would resolve itself. Going back to this, we zoom in. Let me zoom in. See detail sheet 4 and 5. Right, we saw that on the unit with the bracing. This one they're not sharing. Wood walkway. That would have been a wood walkway back then. Probably current day too. And it's hard to read this stuff. Can't read the top. Longitudinal strut, upper chord. Same for floor beam. Okay, so I don't know what they mean by same for floor beam, because that's obviously a different detail than floor beam. Same for floor beams. Floor beams are substantially larger, and so floor beams are here. These are the floor beams, which they're saying. Let me zoom out. And that's the top strut. Floor beams obviously designed to take a load, and that's designed to keep the bridge from folding inwards. Apparently, remember the person who designed the bridge is dead, and there we go there. And moving on, we have back to my drawings here. So we're at page 2, and there's your two spans, 1 and 2, and it's just beautiful. It's just beautiful, this suspension bridge. Suspension bridge, iron suspension bridge. I find that awesome. And this bridge was moved to this location. Little what? It keeps moving. Oh, the river below it. And moving over to one more. And Baltimore and Ohio Railroad, Bollman's Iron Suspension and Truss Bridge. All right, so here's the and Truss Bridge, circa 1869. And let's read the details on this real quick. The Bollman's Bridge at Salvage, Maryland, is significant. You know, it's called Savage rather than Salvage. because it is the only known existing example of the first bridge type consistently used by a railroad. So this was the first bridge they made, and is still the existing only bridge in the world of this design. So this is the one-off. The one-off in the beginning that then became 99 plus. This is the one that survived, which is amazing, right? And it's the Historical Society, everything else, Engineering Historical Society. Let me scroll over one and see what we got here. The bolt is a two-span truss resting on granite abutments at each end. Where I'm going to show you the combination. If you guys look at the right here, wrought iron and cast iron. It's just beautiful, the combination this person used of the different metals. And this show, and 150 years later, we're going to see the real detail of it up close. But 150 years later, this is still, going strong. I find it amazing. Find it truly amazing. Let me scroll over a couple more tabs. And this is someone else. American Society of Civil Engineers nailed it as the first civil engineering historical product, and it was the first. This was the first of the label, being labeled the first of their engineering feats. It's the #1, so we'll see that too. So it's #1 in quite a few things, and it's still lasting. Let me bounce over one. This is the so I did some more research trying to find other Bollman truss. Of course, if it's the only one existing, I won't find another existing. But I found photographs under bridgehunter.com. It's got 2 images or paintings. I'm not sure what they are, but look at it. There it is at the truss design, and how simple. And there it is again, and that's the skewed, rather, not offset. Skewed. No, it's not skewed. Those are parallel. Just the last couple of members are skewed. So I would think of that as like a skewed vertical post, end vertical post. Let me think about that. So the load, no, I would call the entire bridge skewed. Correction on that, because that's the vertical post, that's the vertical post, vertical post. Thinking of this guy's design, and all of the structures coming down to their suspension. So skewed suspension bridge, all iron. It's just beautiful. And I was really going to do a video of you guys talking to you about Pratt bridges, and then do one bridge at a time, explaining how Pratt bridges and Warren bridges work. But I decided to involve you guys on my trek tomorrow of the Bollman Bridge, and let's see if we can find more yeah, that's Howard County, and that's where we're going tomorrow. It says it's got 33 images. This is the current road in 1970s image, something like that, 80s. Well, we're going to see it. Oh, that's a high up view. Well, we've already got a closer view of it. Okay, so there's the anchors right there. Let's see if I can zoom in for you. So there are the anchors that tie this bridge together, and there's the through port, if you will. I'm going to look for a rust. There's a riveting system. I'm going to look at all this stuff, the city conditions and everything else. Look how this even wraps around there, like it grabs it, if you will. I can't think of another word right now. I do have a few in my small brain, but nothing's coming up to mind right now. Actually, a lot of things are coming to mind. I just can't make it stick. Can't voice it. Now, I guess I should have checked to make sure you guys can hear me. And as you can see, no connection. No connections. No connection here. Huh. Interesting to see if these are parallel or not. No one's going to adjust this bridge now. That's not needed. But again, here's your slide going up and down, and there's your adjustment. I think it has multiple adjustments for each one. Adjustment, 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 each one so this one, if you follow it down, has another adjustment here, and another adjustment here, and another adjustment there, which simply would be adjusting the furthest one out. So the loads do come back down onto this one, which then transfers back to back through this member here. So that you can imagine this top adjustment, as it puts the load back down, through, and a shearing point also on that adjustment. It puts the load back down through this upright vertical, which then transfers it back to its bottom load member. Interesting. So if you follow that load path, if this one transfers down to there, this one transfers down to there, it has to transfer it over all the way down, each one, sharing the loads down. This one you would think would have the most load on it then, right? Out of all of these members. So I'd like to see tomorrow if this member is thicker than this member. Did they progressively get smaller, or did they just size them all the same? And moving on. Hey, can you guys hear me? Can I get a little shout out, a little hello down there in the comments? I'm just refreshed the screen. And wow, it's just beautiful. It's just beautiful. I'm just evaluating stuff I'm going to be evaluating tomorrow. Look how they have all the holes in it for casting, I guess. Huh. It's just beautiful. You guys hear me? Oh, this would be terrible if you don't hear me. You guys hear me? Okay, yeah, I'm really interested in that detail there. And I want to see rust. I don't see much rust here. I do see where in the images I keep looking for. I did find it where it's on one of the piers. I'm going to be looking into that. This looks connected, right? This is confusing to me. This is where the two structures meet. And yet I saw images where it was not connected. Huh. I'll have to look at that. That's the walkway side. I'll keep that in mind. Can you hear me now? Yeah. Can you hear me now? Can you hear me now? Thanks, Robert. I'm going to take my laser along, so I'll get heights and widths, whatever. Huh. That one's interesting. I'm going to have to look at that. And what are these? 1, 2, 3, just ports. Okay, my eye lost it there. Clearly see it. It's sky. It's sky. Now these are tapered. I did notice that they are tapered in design. Interesting. This is supposed to be granite from what I've discovered. It's just loaded granite. But ultimately, this bridge doesn't need too much of a abutment, because it's just, hold on. It doesn't need too much of an abutment because all the loads are just, it's not pulling from the ground. This is like a free, if you could lift this would be an ABC bridge. You could lift this bridge up and move it somewhere. I want to get here back in time. Yeah, John, I'm not sure. Justin, I'm going to, I guess I got to figure that out now with you guys, huh? Not like if it's raining tomorrow, right? So I'll have to do a, yeah, good statement. I guess and I'm scared to put the, it's already preloaded and say that it'll start tomorrow, because what happened last time is I did that and it wouldn't let me, oh yeah, I can do it from my cell phone. It started 2 videos at the same time. You guys remember it screwed us. So yeah, I'll do it from the cell phone. That way it'll be consistent. So I'll set it up, Justin. I'll do it. I'll do that. John, right? Justin, I think you remember John. Yep. I'll do that after we hang up, and we'll figure it out in a moment. So look at this thing again. Again, it's like a cable stay bridge, but these are, if you think of it that way, these are wrought irons. But number one, this guy is amazing. Let me show you why I find this guy so amazing. Remember, he followed. Come on, where you go? Backing up. Backing up. Bollman. Okay, yeah, you guys got to load that app. Oh, you're going to be so addictive. And try to get 3 nuts and what it amounts to. Yeah, there's some other research I'm doing for you guys on the bridges. So load this app up on your cell phone. It's called Trust Me. It aggravates you now. They do have a little quick video to help you play with it. And then ultimately you want to get 3 nuts. 3 nuts to do it. Now keep in mind that try to think of a Warren truss, like a W when you do it. Try to think of, and have some fun, like an arch. Try to think of a Pratt truss. So Google, I guess I didn't get to that yet. I wanted to show you this, guys, and also do Pratt at the same time, so you guys can play with. it. I wanted to show you that. But just play with that, and we'll get back to the truss thing. Now, I haven't gotten my 3 nuts. I've gotten 3 nuts on it. Maybe I think I got 5 bridges with 3 nuts. I'm like, really? I keep changing the design, trying to get the ultimate 3 nuts. You know, it is funny, right, to say that. But when you play with this, it's gonna eat some hours up. It's a lot of fun. I've turned on a few of my engineer friends too, and they're pissed at me also for turning them on to it. It's quite a challenge and quite a lot of fun. Where's my man? I'm trying to show you that he was a carpenter. If you Google this guy. Okay, 1966, the American Society of Civil Engineers introduced a new program that designated the bridge as the first ever historical civil engineering landmark, which we're going to find tomorrow. And that's not what the landmark looks like. It looks like a plaque on this bridge. The bridge was listed in the National Register of Historical Places on 1972. He was designated blah, 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 right? $214,200 restoration contract was with Dewey Jordan, blah, blah, blah. In September of 1982, the bridge was restored by Wallace Montgomery. They probably removed a lot of the lead, etc. I couldn't find out the restoration, what they did. But I think we'll look for pop rivets. There better be no bolts. Okay, and of course we know to do that. So here again is the structure, the real deal. This is the real deal because there's no color. This is pre-repaired. How you know that? Because it's painted now. So this is what it looked like bare metal, which is awesome that they loaded it up because now you can get to see it without the pollution of the photographs of the paint or oxide. Awesome. And these are dummy nuts from what a dummy, they call them dummy nuts. And it's funny that they call them dummy bolts or dummy nuts. And yet, this is pop riveted. No, I'm getting my bridges mixed up. Wait a minute. I'm doing something wrong here. It just hit me on something on the pop rivet thing. Come on. Where are you? Great. It just hit me on something on the, oh, this is awesome. On the pop rivet thing, hold on. Right there. Pop rivets. Apparently pop rivets. Gotta make sure the pop rivets there tomorrow. Yeah, I can't imagine them being bolts. It's the same as the Philly Bridge, right? And so there it is, pre-paint. Looks pretty damn good. So I guess that 200 grand went to painting because I don't see any significant. I'm trying to get this thing to zoom. Great. Great. There it is painted. So my guess is most of that money was blown on the oxide, the coating. Oh, this is going to be pretty. So there it is where the two meet. Huh. I know I showed you a photograph where the two were not meeting up top. The decorative piece now, if you will. They're clearly meeting. Well, they don't call me crazy for nothing. Okay, so that's pre-paint. It appears to be pre-paint also, or, well, pre-paint, then paint it again. Let's move on from there. Again, these are the adjustable rods, adjustable pins. Wish they had more details on the adjustable pins. I just, this guy just sat there playing around, and he came up with this whole thing. Just amazing. A carpenter, born in 1814, and then they followed him. And last image coming up. Oh, we already did last image. And I'll load you the links. Okay. Completed 1852. Yep. Curated the 1850s. The age of intuitive design had been dead for a decade or longer. So he died in 1884, so now they've started following the true deal. Here he is. A self-educated engineer so they call him a self-educated engineer. He was a carpenter. And I guess it's sort of like you're taking away his by calling him engineer now. I feel like you're taking away the guy's master brain, because now you're making him equal with people that had to go to school, etc. This guy did it without the schooling. So I think this is this is taken away from the guy. A self-educated carpenter, who made bridges that engineers followed. This is what I find amazing. More than 100 Bollman truss bridges were built between 1850. Because this is crazy. I mean, not crazy, also Thomas Jefferson was another self-educated architect / engineer. Some of his formulas we still follow today. And let's run through these images. Wow. Here it is. I understand this might be a part they made up, because I understand somebody stole the per one of the articles I found, the portal bracing on that, or they liberated it. You can say stealing if you want. I think they liberated it. There it is, the signage, National Park signage. Here it is again. Here are the adjustments that we're going to look at tomorrow. They just crank up. So again, that's putting that under shear forces. Yet it lasts 150 years. Shear force, sharing, as in S-H-A-R, sharing all of the load on each one of these. It's just awesome. I don't quite get the intent of this. These two braces here, these braces here, and here coming up. I don't get that. In fact, I would think they'd want to buckle if they're solid and you started cranking up on this, shortening it. I think these would want to buckle if they don't have an ability to shrink, to adjust. So I don't understand that one, but I will tomorrow, I think. So that'll be a big quest for me. That'll be a quest for me. All right, what we got here? Sliding over one more time. Quickly and inexpensively while providing the long-lasting qualities associated with metal. Yep, so here we go. We're back to steel being awesome. Steel's always awesome, and everybody hates on steel. Yes, it takes longer to get it, etc. Well, you got a 150-year bridge that everyone can be happy with. Right there, they're not connected. So I knew I wasn't that crazy. They're not connected. So they added that piece there, this decorative bracket between the two of them. This interesting. This piece, these caps. Huh. I'll look at them to try to figure out whether they added or were they always there. I would. Oh, okay, I got it. Photograph. Well, you need a dual span. The photographs they had, I'd be able to see a dual span. It's not there either. What we got here? If I could read that. Oh, United States views, whatever that is. That looks like 1930s, right? 1919 or something. My man dressed up. Maybe even earlier. It's gonna be the best image forever, and that's clearly a cap. Whoa, what's going on here? I feel like I'm in a different structure altogether. So this is a different structure altogether. Look, this appears to be another deck up here, or this is another Bollman Bollman design, another Bollman bridge, not this one, I don't think. Look how long it is. Multiple sections as you go down this tube. Interesting is it went up higher here on this detail. That's the duplicate. Huh. I'll have to give that, and I'm looking for that other one. I said it was kind of odd to me. And there, I think this is it here. This one. I'm going to look at that. Oh, it probably threads. Probably threads on the bottom half. Huh. I wonder if it's a sacrificial piece to even tell them if it's starting to take loads or strains. You can start seeing it elongate or show some failure. And because the guy was pretty smart to build this design, I wonder if he thought of that also. And moving on. This piece here is what's got me. It's the same as this piece, I believe. So we got the debris on the tracks and all that. So this will be a good view of what's going on with the structure. Pre-paint. You can see the cast iron, some nicks and chips. Oh, it's beautiful. And that's just solid material, so no water is going to penetrate it and cause, you know, freeze-thaw cycle issues. Just beautiful structure. Look at it. There's some little. So I'll definitely take a look tomorrow to see if we can find things like this, or did they somehow patch it, which would be. I guess that would be fair play, but I don't know. It's just beautiful, and it's just a pin up here holding this together. And these are just bars. Awesome. Awesome. And there it is again. And that's the opposite version of it. 1, 2, 3, 4, 5. 5 bays. And there's the cross bracing, lateral bracing. And he kept that all the same size. But yet the bottom of the structure, scaled it down. Turned it into an I-beam, almost a railroad track. I-beam design, right there. Huh. Back out. I don't know what that is. I thought I was going to show something. And scrolling through here real quickly. Not connected. No caps. Somebody's liberated a piece of material there. Half painted. 1983. Okay, right below me. The 1982. Prior to 1983-84 rehab work. That's awesome. So their rehab, so before the rehab work, I'm trying to see if we got rivets and all that stuff like that. So I have more images. Now you can see that. There's the deck there for people to walk through. No, looks like mostly paint. $280,000 in paint. I'm okay with that. Back then, that was some good money, right? All right, let's see what else we got. Went through there. 1982. Went through there. What's up? What's up, Blind? Robert, the FIU engineering staff and students should make a field trip and look at this bridge. Yes, Robert. Yep. Yes, Robert, agreed. Agreed. Now here it's finished, right? They put the cap on top, white and red. I think that's pretty awesome. I mean, I'm okay. It's awesome that he took care of it. Look at it. Suspension bridge. So again, this one would be just loaded here. So he kept it all the same sizing, although that appears to be larger. Zooming in. Remember, this guy's a self-taught engineer, as they say, right? So this connection here I find interesting because this would hold the whole bridge. This floor beam was being held on by, I want to see the connection. What's this floor beam being held on by? It's like a clamp. And it's held by the top, if you will, like you're reaching down and grabbing a basketball. I wonder why. I guess it keeps it stable. And here are your two balls. We saw that in the photo 2 or 3 I showed you. The two balls going through here. And so, yeah, that's just a sway. Like I keeping it locked in. I'm going to think nothing more of that. And all your loads are in threaded bolted connection right there, 1 and 2, which I don't see it going through the top here. So if you guys ready for tomorrow when I do this, we'll look here, if you remind me, and see where they end up. They end up here. And then how's the connection made from here to there? Here's this rod coming down. This rod coming down. This one going through. Let's see if we can find that in there. Image 2, or is it nope. So how was he? Okay, there's a cutaway of it. Page 4. So going through there, there's that part that I was fascinated with. Can't tell anything here. Bottom pin. Top pin. Oh, great. Well, there's the top. That's for the cord. But I do see a through rod. This rod here, right? A single. Gotta bring my ladder, right? I don't think you think I'm joking? I might bring my ladder tomorrow. I don't forget. I've got a mobile ladder, small enough. 16 foot I can see the top of it. What do you got here? And note that there is a center column. What do you say? Center column. John, what are you talking about? And note there is a center column. This connection says link. This is for the cables, if you will. Bottom pin. Double intersection panel bracing attached to bottom pin of compensating link. Compensating link. So this appears to be a link. Really, you're killing me here. Let's bounce out. So in there, these pin, 2 pins, 1 and 2. Compensating link between here and here. Might be a link. Looks like this, perhaps. Literally like a bicycle link. But you got 2 rods. Huh. Turned in that plane. All right. Let's see if we can get another close-up of that. Let's bounce on. Take a drone. Yeah, they got a drone image of it. Take a drone. I do have a drone, but then you guys will never see the image. And I got to play with my drone. Next thing you know, be playing with myself all day. Get it? All right. Here's that view. I do have a drone though. But sometimes they don't allow it in parks, right? I don't even know what the rules are anymore. Can't fly over people. Everything else. Here's the linkage again, compensating link. Okay, so there's the bottom link. So this comes in, ties here. This link ties to there. Okay, so this transfers the load immediately. This is just a standoff, if you will, at that point. So it transfers the load immediately from here to here. This is a truss plate, acting as a truss plate. And these are the cables, which in case of the solid bars. I got a Phantom 3. They have prices for something. Well, you're not going to like me. I did a video about how I don't like DJI's products because I got hold of DJI. I did multiple videos, if you find it on there. Got hold of DJI, and they refused to let me fly their drone unless they give me access to your photographs, your all your data on your phone. They just have access to it. And also, say you're flying over that structure, and it's a structure you can't fly. You agree to allow them to call the cops on you, basically. Not basically, you do, and they can send your data and all. So you agree to help prosecute yourself. I think I'll pass on that because, you know, I go a lot of places, and I mean I've gone places where I'm taking photographs. Next thing you know, photographs and videotaping the structures, and this, you know. And security showing up saying, hey, you can't photograph this structure. I'm like, well, what is the structure? You know, then they'll tell me, and I'm not going to share with you guys. I'm like, oh, to me it just looked like, you know, an amazing piece of steel and engineering. And yet they're disclosing to me that, no, behind that amazing piece of steel and engineering is, you know, something that, that they consider protected. I usually respect them. Clearly now they got laws. You can photograph what the hell you want to photograph. They couldn't stop you. But that was a few years ago that last happened to me. But I don't need that violation. I don't need that drama, rather. So, yeah, I don't need that drama. I can't be bothered with that. All right, so back to this. So here we got this pin. There's a threaded eye bolt suspension floor system. So suspending floor system from compensating link. Yeah, there it is. Oh, glad I did a good evaluation of that, at least per what they say also. From compensating link. Oh, I feel good. I feel like patting myself on the back for that one. All right. Cast iron end cap. Bottom cord member of lateral bracing. End panels only. Okay. Bottom cord member of lateral bracing, end panel only. All right, so what they're saying there, I don't know why specifically, is what I keep pointing out, saying I find it's a different, you know, that he did it a little differently. This right here, these are what they're referring to as panels. If you and I were going to dissect this, we'd take it from here to here. That would be our section we're dissecting, but nevertheless, the Smithsonian engineers refer to this as panels. 1, 2, 3. And so this panel, they thought it was significant to mention or document that bottom cord member of lateral bracing and end panel only. Okay. Lateral bracing. I would have lateral bracing. I'm just trying to get the visual of that. Yeah, I can't find, you know, so if you're looking at the side of the bridge, that would be the lateral bracing they're referring to as, at least now. We have something to go on what they're referring to as lateral. Okay, here's the tops, and as you can see, they're not. How do they bond these two together? Because remember, this is like prefab. There we go. Upper cord lateral strut. Don't know. How do they keyway these two together? Double intersecting panel bracing. So this is what I wanted to see. This, what are they calling? Double intersecting panel. Look at the comments real quick. Yeah, nobody came. Yeah. No, I didn't even have a drone. It was just a regular camera. It was in California. You know, you Californians are weird. Main diagonals in the middle of the damn desert, you know, out of nowhere. Compensating link. Awesome, though. They do have measurements. 24, appears to be 2 feet from here to here. So that'd be, let's see. Yeah, that's nothing for me. Floor beam. Oh, good. There's a cutaway of the floor beam. Floor beam, 12 5/8 by 24.5-inch box girder, cast iron, top and bottom, and wrought iron side plates. Oh shit. So it's got a cast iron top and bottom, cast iron, and wrought irons on the side plates. And they don't tell how they're secured. So this was prefabbed again. You know, the whole unit, not rolled or put, you know. This is 4 pieces to make this floor beam. Now here's a cross section, diagonal brace panels by floor system. Floor beam truss rods. I think that says truss rods. Okay, so that's going to resolve that there.